Hello learners, welcome back to my channel Shraddha's Physics. In this part we will see some properties of the beta function, and that after we will solve some problems related to it. So these things we have already discussed in our previous lecture, that is your gamma function, and also we have solved some problems there. Now in this video we will discuss on the beta function. So this beta function is specially denoted as, suppose this is your beta of mn. These are the variable. It can be denoted as equal to gamma of m into gamma of n divided by gamma of m plus n. And here the real part of m and the real part of n, it should be greater than 0. Okay. So this is the basic properties of the beta function. Now the next representation, if we will discuss, just a minute. Yes, if we will discuss the next properties of the beta, suppose this is your beta mn. This can be written as equal to m plus n divided by n whole into beta m and n plus 1. Okay. This representation can be directly asked in your exam. So the next is this beta mn also can be written as equal to n minus 1 divided by m, and here the beta is the function of m plus 1 and n minus 1. Okay, so just try to remember all these things. And again the next is, if beta m comma n is multiplied with beta m plus n comma p, that will be equal to then beta of m comma n plus p and beta of n comma p. And also the properties like beta of mn, this is equal to beta of m plus 1 comma n plus beta of m comma n plus 1. This is your n plus 1. Okay, so these are some important formulas related to the beta function. Now also you should remember that the beta function is symmetric with respect to m and n, that is beta of mn that is equal to beta of nn. And if you will discuss about the transformation of the beta function, if you will discuss, then this beta mn can be written as equal to integration from 0 to infinite y power n minus 1 into dy divided by 1 plus y whole power m plus n. And also this can be written as beta of mn equal to 1 by alpha power m plus n minus 1 into integration from 0 to infinite, this will be y power m minus 1 into alpha minus y power n minus 1 into dy. This is very important relation, that is beta of mn equal to 1 by alpha power m plus n minus 1 into integration of 0 to infinite y power m minus 1 into alpha minus y power n minus 1 into dy. Okay, and if I write this beta function in terms of the trigonometric function, then this beta mn can be written as equal to 2 into integration over 0 to pi by 2. This is integration from 0 to pi by 2. Okay, sine 2m minus 1 of theta into cosine 2n minus 1 theta d theta. But the common use of the beta function that we already use, so in general that we use, that is beta mn equal to 0 to 1 x power m minus 1. Basically this function we use 1 minus x power n minus 1 dx. This is your commonly used beta function, that is beta of mn equal to integration from 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx. Suppose for example, the question is given 0 to 1 x power 4 1 minus x power 3 into dx. When you will see this type of question, that is x into some 1 minus x or y into 1 minus y. So just remember, this is your beta function. By using beta function you can solve. And you know this beta function, that is beta of mn, can be written as, here the integration value is important, that is from 0 to 1. This is your x power m minus 1 into 1 minus x power n minus 1 into dx. This is the representation. Now you will compare the power of x with this, that is m minus 1 equal to 4. If I will write m minus 1 equal to 4, that implies m value will be equal to 4 plus 1, that is 5. And similarly 1 minus x power n minus 1, this is 1 minus x power 3. So now if I will write, this will be n minus 1 equal to 3, or this can be written as n will be equal to 3 plus 1, that will be 4. So we can write this is equal to beta of 5 comma 4. Okay, and you know beta of mn can be written as, this beta of mn, it can be written as gamma of m into gamma of n divided by gamma of m plus n. So in this way you can represent the gamma function. Now for this I can write, this is your gamma of 5 into gamma of 4 divided by gamma of 5 plus 4, that is your gamma of 9. And also in the previous lecture we have already discussed that gamma of z plus 1, it is equal to z gamma z, and also we can represent this gamma of z plus 1 is equal to z factorial. So now in this part, if I will put gamma of 5, that is gamma of 4 plus 1, that is 4 factorial. So here I can write this is equal to 4 factorial into gamma of 4 means this is your gamma of 3 plus 1, that is your 3 factorial. So here I will write 3 factorial divided by gamma of 9. 9 means 8 plus 1, that is your 8 factorial. So that will be 8 factorial. Now how you will solve? This is your 4 factorial into 3 factorial means 3 into 2 into 1 divided by this 8 factorial can be written as 8 into 7 into 6 into 5 into 4 factorial. So this 4 factorial get cancelled. 3 into 2, that is your 6, get cancelled. So the answer will be 1 by 8 into 7 into 5. So that will be 7 into 5, that is your 35. 35 into 8, that is your 1 by 280. So in this way you can solve. This is your direct question can be asked. That is, you have to just check it is in terms of x power something into 1 minus x power something. Okay. And also you should note that this beta of mn can be written as beta of mn. This is equal to m minus 1 factorial into n minus 1 whole factorial divided by m plus n minus 1 whole factorial. This is minus 1. Okay. Beta of mn equal to m minus 1 whole factorial into n minus 1 whole factorial divided by m plus n minus 1 whole factorial. So this is all about the beta function. So you may solve this type of question specially, and just try to remember all this formula. If you have not watched the gamma function also, just try to watch that video. This is all for today. Thank you all.